Hello everyone, this is Professor Maloney, and today I'm going to be doing yet another video recording, and this one is going to be the first video recording for Chapter 6. Last class, which was last Thursday, let's see here, the 21st of this month, I gave an overview of Chapter 6, specifically talking about the functions and the value returning functions versus void returning functions, and also about variable scope, talking about global variables and how big they are versus local variables or static variables. So today I'll actually be building one program that we did in the last session of Chapter 5. And the last session of Chapter 5 was 1 week ago from today meaning now the 26th, because it's technically the day before that I do my videos. But anyway, that particular video was covering Chapter 5 for loops. Okay, so what I'm going to do today is build on that one and throw in a value returning function prototype, because that'll also help you remind yourself of what we learned in Chapter 5, because you've got your second test coming up here on November the 9th. Okay, so that's more or less 2 weeks and a bit away. So that particular exam will cover Chapter 4, Chapter 5, and Chapter 6. And if you recall, Chapter 4 was if statements. Okay, it was also switch structures with case statements. And then Chapter 5, we introduced while loops, for loops, and do while loops. And now we're in Chapter 6. And like I said, last class, which was last Thursday, I gave an overview session on Chapter 6. And today's session will be to build, where I'm actually building a program like I've done for the other chapters. So this one, I'm going to take the Chapter 5 for loop program and show you how we can turn that into a function to allow us to get the number of fill-ups that the user wants to use in the program. From a function instead of just from a simple COOT statement and going straight from int main down. Okay, so let's go ahead and start sharing my screen here. Okay, so I shall take that off, go over here, and now we're going to go into REPL. Okay, so I'm going to hide that, and I'm going to get out of here and go into REPL. Get out of that. So I'm going to create a C++ REPL, and we shall call it Chapter 6, value returning, value returning, but I'm going to make it less than that because that was just something we're going to be building. So chapter that, okay, and I'm going to go ahead and create that REPL. Okay, now, as always, they give us just a few lines of code to start our program based on C++. What I've done is copy what I wanted from Chapter 5 so I can give you a quick little review on what I did last Tuesday in class. And then I'm going to have talk about what I'm going to do and then show you a demonstration for what you're going to do. Okay, so let's see here. I've got these fill-ups already in, so I don't need them twice. So let's get rid of this one comment. Okay, and get rid of another one of these lines. Okay, so this is a Chapter 6 value returning function example, and it's going to be based on the Chapter 5 for loop I demonstrated in class last week. All right, so this particular for loop example, if you recall, was to allow us to have a user enter how many gas fill-ups they wanted their program to be based on. And I said, you know, in class we'd base it on 3, but the program would work for 33, it would work for 3,033, it would work for 3, it would work for 1, it would work for any number you want to choose, right? And that's why we're letting the user input that number with a C input statement. And it's going to keep track on the number of fill-ups, and then it's going to ask the user how many miles was driven for each of those fill-ups, how many gallons we had to use in each of those fill-ups, and then it's going to do a calculation for each of those fill-ups on the miles per gallon for the particular fill-up. Okay, so this code is already done. What I'm going to do today, you know what, let me make this a little, I think it's probably big enough. But if not, I'll come back and alter the size of it to make it larger. Yeah, so what I'm going to do is take the code I've already got down here, okay, and change it though. And this is what you need to learn how to do. So I'm going to have a student challenge too. But what I'm going to do is change it so that the number of fill-ups that the user wants to allow us to do is going to be retrieved from a function instead of from int main, okay? So that's what I'm going to do. And you recall on Thursday, last Thursday, in my Chapter 6 overview video and our class discussion on it in class on Thursday, I talked about how with functions, there's three parts of a function. One is a required function prototype. And the function prototype must be declared above int main. So line 11 right here is int main. So the function prototype must be put in on line 10. Okay, line numbers, as you know, don't matter. They do not matter. That's just where I happen to be here. But I'm going to be putting a function prototype. So let me start with putting a little comment. So using a double function prototype to set up this program to use a function definition and a call from int main to the function definition. I'll just say to the function. Okay? So that's what this is going to do. And if you recall, I also said if it's a value returning function, we start with the data type. So in this one, it's going to be a double. If it was a value, not a value returning function, then we could use what we call a void. And a void function just means it doesn't return a value. It still can do calculations and that stuff, but it doesn't return anything to the calling procedure. So we're going to be doing a double, okay? And I think I may have told myself what I'm going to name it up here. So let's see. Yeah, double, and I'm calling it number of fill-ups, okay? So double number of fill-ups. And remember, in this class, the way I do everything is the first word on a variable would be all lowercase. The first letter of each subsequent word, so in this case, the word OF, is going to be capitalized. And then the next capital word would be fill, so that's capitalized, and then U for ups. So I'm spelling it as double number of fill-ups, and it has to have a required argument. And this one I'm going to use an int, and I'm just going to call it number, okay? All function prototypes end in a semicolon, all right? Now, normally a double data type would have a double data type within the argument, but it's not required as long as they're still the same, they can be turned to the same type of data. So like an integer, as you know, is a whole number, but a whole number, like the whole number 10 is 10.0 in the double world, okay? And the reason I'm doing it this way is in case I want to demonstrate something else in a future programming video demonstration for you. So I'm just making this was an int number, and that is perfectly fine. So now I want to get the number of fill-ups not from in here in int main. I want to send us down here and have a procedure down here. So I'm going to copy, just like I talked about, this is the demonstration, just like I talked about in class last Thursday in my video, and our talks, our discussions, our question and answers, etc. I'm going to now copy this function prototype, okay, and paste it in under int main. Remember, after the closing curly brace, which closes int main, this curly brace right there is the one that opened right up here in int main, okay? So under it, that means int main is now closed. So I'm going to paste in the name of the function prototype. So here I'll put another comment. And this comment is just going to say that this is my function definition, okay, where I place the code necessary to do the work the function is going to do, okay? All right, so, and I'm going to have it as double number of fill-ups. It has to be exactly the same name as the other, and the definition needs an opening and closing curly brace. So I'm going to put an opening and closing curly brace right there, And this, where my cursor is blinking in line 38, is where the code is going to go. Okay. This little red squiggly is because there's nothing here underneath. Oh, actually, I got to get rid of the semicolon. And then I've got to put my code within the opening and closing curly braces. So when you have the definition for the function under int main, you do not put a closing semicolon. This is like when we did our if, our switch, our case, our while, and our for loops. In the expression, there's no semicolons on that line of code. All right. So I'm going to, though, put some code which is currently up here. Okay. And you know what? Before I do that, I want to again demonstrate this to show us that this is what we did in chapter 5. So this program assumes you start with a full tank of gas. If you entered 3 fill-ups with the first one, and the first one was for 300 miles and 15 gallons. The second is for 325 miles and 16 gallons. And the third was for 350 miles and 18 gallons. Again, this is what I did for you with you last week. So the miles per gallon for fill-up number 1 would have been 20.00, and your miles per gallon for fill-up number 2 would have been 20.31, and your miles per gallon for fill-up number 3 would be 19.44. That's if you're using set precision, and I'm telling us we're going to use set precision. Okay, so right now in here, I don't know if I have set precision. I don't, because I copied this, and I guess I didn't copy it from the one with it. But you know what set precision is and how it works, so let's just go ahead and put it in right away. So as long as before I give this output here, this is the miles per gallon, and actually all I'm doing in mine is putting in the number of fill-ups, so I don't need it for there, but I'm going to put it in right here. All right, so I'm going to now put it in a coot statement, and you guys should remember this, right? So coot statement, oh, and actually I don't want it in a loop, sorry. So I'm going to go ahead and put it before this statement. So I'll do a coot less than, and now I want to do fixed, and then show point, and then set precision, and I want set precision 2. Okay, and to do that I need to use IO manip. So let me put in this one a comment using fixed, show point, and set precision to have output with 2 decimal places for MPG, miles per gallon. All right, so that's in there now, but let me go ahead and run it, and now go ahead and do our little thing. All right, so I've got a non-returning, in other words, that's just saying that this function is not doing anything yet. So that's okay, right? It's going to do something very soon. All right, so how many gas fill-ups do you want to enter for these calculations? Remember that when you're looking at any input here from the user, or requesting input from the user, or any output to the screen or to the user, look at what your program's doing. So here it says, how many gas fill-ups do you want to enter? So you look for it. How many gas fill-ups do you want to enter? What we enter is going to be assigned to the variable called num fill-ups. I'm going to put the number 3. Okay, so now 3 is in num fill-ups, and now it says enter the number of miles you drove. See, this is just over so that you can't read it off. Number of miles you drove for fill-up 1. So you go down to look for it. This is the next statement to the user. Enter the number of miles you drove for fill-up, but mine says 1 because remember I'm putting a variable called fill-up num, and fill-up num right here in this for loop is assigned the value 1. So it's going to take 1 automatically, okay? But I have to put the number, and I set up here what my numbers are. So for my test deck, okay, I'm putting 315. So 300 for miles driven and 15 for gallons, okay? And then it calculates the total for me. So, and just to verify that, it says I put in 300 miles for trip 1, 15 gallons, and then down here for fill-up 1, it says my miles per gallon is 20.00. So it's correct. And then you see now it says enter the number of miles you drove for fill-up 2. Because again, this is a for loop. So what happens in a for loop? Well, we increment the counter at the end of it. Let's move this over to get that up there. So fill-up num plus plus adds 1 to this 1 after it goes through the iteration. The iteration meaning the opening curly and the closing curly. Then it comes to the top, and now it's fill-up num equals 2. So in my output, it's automatically picking up fill up num, the variable, which now it has the value 2. All right. So for this one, what did we want? We want it. So the second, 325 miles and 16 gallons. Remember, these are test decks. Test decks are to make sure that your program is doing what it should. So 325, and then I put in 16 for the gallons, and now it tells me it's 20.31. So I come to this part of my test deck, and it says your miles per gallon for fill up 2 would have been 20.31. It is 20.31, so it's fine. Okay, and now back up for fill up 3. So for 3, we are putting 350 miles and 18 gallons. Okay, so here 350 and 18 for the miles for the gallons. And now the calculation is 19.44. So this program did exactly what it needed to do. Okay, so now though I'm going to show you how we can move this and move this. Okay, and then have an assignment statement to pick up a value that we're going to get from this function, but I need to code that function first. Okay, so what have we done thus far? I created a function prototype. Okay, it had to be declared above int main, so I put it in line 11. I said you have to have the data type of the function if it's a value returning function. Said this in my lecture last Thursday. Okay, so double is the data type. Number of fill-ups is what I'm calling the function, and there's one required argument, so it has to have an opening and closing parenthesis and a semicolon after the parenthesis, closing parenthesis, and it has a required argument in between, which in this case I'm using the integer data type, which in C++ the reserved word is int. All right, so int, and I'm just calling it number. All right, so I have that. And I said that the function prototype, which is this, control copy that, I think I already did, must be the very same name, and there it is, so I don't need to paste because it's already here, as the function definition, which is declared under the closing curly brace for int main. So here's the closing curly brace on line 36 for int main, and then I put this double number of fill-ups, has to be the very same thing, the same formal parameter, which is the argument, int number, but now I have to put the code that I want this program to do. So what do I want it to do? I said I want to take now the number of fill-ups that the user wants us to use in the program and put that code in down here in this function definition. So I got to take the cout statement, and I have to take the send statement under it. So let's go back up here. So here we've got a cout statement. How many gas fill-ups do you want to enter? And then we have this C input from the reply variable from the user. So I'm going to copy this. Right? So control C that. All right. Actually, I'm going to cut it. Control X, because I'm not going to be using that now. I'm moving it. So now I'm going to come down here and then control V like Victor and put that in. Okay, and because my argument is called number, I change this here to number. Okay, so now we don't have any squigglies. So here's the function definition, double number of fill-ups with the argument int number. It must match everything with the function prototype. The prototype tells us this is what we want our function definition to look like. So this is the same thing, but a function prototype ends in a semicolon, okay, because it's a code statement before int main. And down here, when it's like an expression, like if statements, else statements, switch statements, structure statements, for statements, while statements, and do while statements. They're all expressions, no semicolon, all right? But now I have the function definition, and I have to ask the user in this particular cout statement underneath this function now, how many gas fill-ups do you want to enter? And I'm going to assign it to the variable number right here. And a function definition, if it's a value returning function, what must it do? You remember from the lecture, hopefully. It must return a value to the user, and in this case, the calling procedure. So here, I want to put a comment, get user input from, or get input from user. Get input from user for number of fill-ups they want. Okay. And here I have to say return value to calling procedure. And remember, the calling procedure is going to be up here. So here I'm going to call this particular part of the program. So it's a matter of just thinking, well, where should it be and where am I right now? Well, I have a function prototype, right? It's right here in line 11. I have the function definition and I've coded it down here in lines 37 through 44. I mean, counting the curly braces. So 37 to 44. All right, so I've got that. And here's what I'm asking for the user from the user. But now I have to call this function definition so that the program knows it needs to come down here to get this information. So what I have to do now is call it. All right. So I'm going to go back into my int main and I want to call it, which means I need to have a variable for it. So where do I do it? Well, it has to be within int main. Okay, so here's int main, and it's going to be after my variables, and it has to be before my for loop. Okay, doesn't have to be before or after the set precision statement to return 2 decimal places, but I'm going to just, and of course these are all just comments, so I'll put it right in here. All right, so I have to call that function prototype. It's a matter of what I want to call it. So first I'll just put a comment here, calling function definition to get number of fill-ups user wants for the program. Okay, so that's what it's going to do. And now I'm just going to call it something. So I'll say it's going to be number fill-ups. Okay, so remember, we had to do 2 things when we're using the function, actually. So let me first have a variable. So number fill-ups will be a variable. So I need another variable here. Okay, so I'll just put it right underneath that one. So number fill-ups, okay? And this one is going to be, did you mean number of fill-ups? No, because I haven't done anything with that yet. So this one here is going to be a double number fill-ups. And then I'll fix this thing here when I do my coding. So this is what I'm going to put here, to use from, to use for user input response. Okay, so I'm going to have here number fill-ups, and this is going to equal, because I'm going to get it from the user in that particular area. And what do I have to do here? I have to call, remember, the function. And the function prototype are exactly the same name, this part. So I've got to spell it exactly this way. So number in lowercase, capital O, lower f, capital F, lower ILL, capital U, and then lower PS, and then I have to put in an argument. All right. So number of, but look, you know that C++ will give it to us. So there it is, number of fill-ups right there. Okay. And it even tells us that's the base argument. Well, you can't use the data type when you're calling it from int main. So here we just use whatever variable we want to have. Okay, so for this thing here, I already have a variable called number fill-ups right there that I just created for it. So let's say number and then fill-ups. Okay, so now we have that, and we have to, of course, end that with a semicolon. So we're calling the function definition to get the number of fill-ups user wants for the program. And the user in this return statement down here, return number, that's going to return to this variable right here, number fill-ups. Okay? All right. So now we have that. Now let's go look at our for loop, make sure that it's going to be A-OK the way we coded it. So for fill-up num1 equals 1. This was from chapter 5. I don't think I'm going to have to make any changes, but let me just review it here. So fill up num equals 1, and then fill up num is less than equal num fill ups. Well, here it's now number fill ups. So number fill ups is what I'm getting from the user, number. So I want to now call this number fill ups, okay? and then fill up num plus plus, because I want to always increment it by 1 so that we're getting from 1 to 2 and then to 3. And once it is less than equal 3, equal is the highest number, so that will stop. It won't be able to go to number 4 because that's not less than or equal to 3. All right. So that is now, this should now be good. So let's run it, and then I'm going to have you take pictures of it and run through the explanation one more time. All right. So let's run it to see what it does for us. So how many gas fill-ups do you want to enter for these calculations? But now let's see where the program is finding this. Okay. So let's start up here. So here is where the program starts, line 6. That's our IO stream. That's just our input-output stream that you've been using since chapter 2. The pound include means the library, the header file. And then the pound include for IO manip, because we want to use set precision. If I didn't have this pound include, then I couldn't use set precision down here. Okay, where I used my set precision. Where's my loop? Right here. Okay, I'd have a squiggly if I didn't have declared the pound include for IO manip. Okay, so then it comes into the function prototype I declared, right? And it's looking for this thing here to make sure it's A-OK and it has no problems with it. It's looking at my variables, no problems with any of them. It's looking down here. Now it's saying, uh-oh, I'm calling something. Where is this something? So it looks for number of fill-ups. There's no squiggly, which means it's fine. It found it. And it found it right here, number of fill-ups. And it's got a required argument, int number. Down here, doesn't matter what we call it, okay? We're calling it here number fill-ups. That's perfectly fine, because down here it's from the user. The user doesn't know anything about a formal parameter. He or she is just putting in a value that matches the argument, okay? They're told enter the number of fill-ups. So they're typing, in this case, the number 3. So then, though, the program's still not, it doesn't have any code for this. So now it's looking again. It found the function prototype. The function prototype needs the function definition to have the work. So now it's going to go down here, and here's the number of fill-ups. This is the function definition. We're outside int main now, and here's where you see how many gas fill-ups do you want to enter for these calculations. There's the question. How many gas fill-ups do you want to enter for these calculations? So over here shows that we're here. And now the number we enter, which I'm going to type as 3, will be assigned to CIN number. Okay, so now it's taken 3, and then the next statement, you don't see it, but it returned number, which is 3, to the calling procedure, okay, via this argument. So it's, even though it's number here, comes up here as number, it's got to return that value. This value in this case is 3 to the calling procedure. So here's where the calling procedure was, okay? But the equal sign here means the assignment statement took that number and assigns it to number fill-ups. So here is the number 3. So now in our for loop, okay, number fill-ups is 3. So we're starting at number 1, and we're going to go until we get to number 3. And each time we run it, we're going to increment it to go from 1 to 2, and then to 3, and then it will increment to 4. But 4 won't pass because that's not less than equal to 3, and then it stops, okay? So now it says enter the number of miles you drove for fill up 1. So look down here. So now we're in the loop. Enter, so we're on line 30. Enter the number of miles you drove for fill up num, okay, which is right here, fill up num. Right now it's 1. So we're having to now put in the test deck information again to verify whether my newly edited program to use chapter 6 functions works. So I'm going to put in again the same one. So for the first fill up, 300 miles and 15 gallons. So 300 and then 15 for gallons, and it did calculate it. It says fill up 1 would have been 20.00, and there it is, 20.00, and now it says enter the number of miles you drove for fill up 2. Why fill up 2? Because remember, it increments. So down here or over here where it's fill up num plus plus, that's now 2. Then it's going to come down here and say enter the number of miles you drove for fill up 2, and that's what I just saw, okay, right here. So now I had to pull up the second test data. So for the second one, it says 325 miles and 16 gallons. So 325 and 16. And now it tells me that particular fill up my miles per gallon was 20.31. Right here, your miles per gallon for fill up 2 would have been 20.31. It was. Now it wants fill up number 3. So it's back to the for loop, right? Now that we're on fill up now we're at 3 because it's been incremented to 2, and then it was incremented. And once it's incremented, as you know, it goes through the opening, closing curly braces. So for each iteration, it's going from line 30 to line 34, and then back up to the for loop to see if it can still run. Excuse me. Okay, so now for number 3, what's my test deck tell me to do? Remember, test deck to help us. It verifies what we want. If what we want to run works or not, then it'll pass the test. So number 3 is 350 miles and 18 gallons. So 350, and of course test X can be anything you want, right? But you have to test it and sufficiently well. So this one should have a calculation of miles per gallon of 19.44, and that's where it is here. Your miles per gallon on this one, 19.44. All right, so that worked perfectly fine. Now I want you to take pictures, and then I shall demonstrate what we did. All right. Okay, so take a picture from line 1 through 4. It's just telling you what we're doing. These are obviously just comments. All right, so you have 10 more seconds to take this picture. All right, 10 seconds to take this picture so that you can use this to help you afterwards with the student challenge, which I'm going to show you. And if you can do the student challenge and do it correctly, you will get 1 free programming exercise with a grade of 100. Out of programming exercises 6-1 through 6-6. In other words, one of those 6, I will give you an automatic 100 for. You still got to do the other 5, but only if you get this correct. All right. Okay, so I'm going to say you've now got that picture. All right. So now I'm going to go down to line 6, and that'll take you down to line 22. All right. So take this picture, and this one is covering the start of the code down to the calling procedure, actually. Number of fill-ups equals number of fill-ups, open and close parentheses, the required argument, number of fill-ups. That's the calling procedure, as my comment in line 21 says. All right, so 10 more seconds to make sure you get that picture. Okay. All right, so now after line 22, I'll go down to line 23. Line 23 is actually a blank line, but that's okay. And then we're going to, well, you know what? I want to make sure 23 is not real important because there's nothing in it. So I'd rather you make sure you do see that the closing curly brace there. So let's get that. Yeah, I'll just do it. You know what? I'd really rather the other be there too, though. So I'll say with each iteration, off loop. Let's get rid of the, see if loop comes up. Yeah, okay. So because I did have the first picture go through line 22, so I don't want you to think you missed something. So now take a picture from there, line 23 to line 37. Okay, and let's get that cursor not blinking there. Okay, take a picture of that. So line 23 to line 37. 10 more seconds. Okay. 5 seconds. Take your picture. So this is picture 2, and there should be hopefully just one more. So now that's through 37. So now I'm going to go to 38. Let's see, 38. Okay, right there. It's not quite enough. Let's see, how many more are there? Oh, there's still quite a bit to go on the student challenge. Okay, you know what? I think what I'll just do is end it. No, I'll just do what I can anyway. So we said 38. Okay, so just do 38 down to where you get this in the function definition line, and then I'll still do one more. Okay, just to have the other one for you. I'll just show in the next one just the student challenge. So go ahead and take a picture there. So it's lines 38 to probably 2/3 of line 47. As you know, comments, they extend line from line to line to line, but it's only officially called one line. So this is all line 47, and there's more to it. All right, so this is your challenge. So while you're taking that picture, let me read it. So create a double function prototype above int main. So just like in mine, I put it above int main, and I'm telling you what to call it, double. That's the data type. Miles driven calc with a little m, a capital D, a capital C. And then open parenthesis. In this case, there's two required arguments. Double miles this trip, comma, double number gallons. Close the parenthesis and put a semicolon. That's your function prototype. Okay, then you're going to have to figure out where to call the function miles driven calc from int main. Just like I demonstrated where I put the function to call number fill-ups. Okay, my function, number fill-ups, and you're going to have to figure out where yours is going to go for this one. All right. Then you're going to create, so you created the function, then you have to create, the function definition after the closing curly brace, meaning after this thing here. That's where you're going to put your function definition. And the function definition, you're going to have the same name as the function prototype. So it's going to be this thing here. Let me see, you have to figure out where to call. I want to named it right here. This thing here, I'll give it to you like that. That you can copy that once you have it in place as the function prototype with the semicolon, but then copy it without the semicolon and paste it basically in line 47 if you start exactly where I am here. So after the closing curly brace on line 46. So that's what you're going to have. And then anyway, read the rest of this, and then I'm going to go to give you a bit more. So that then it comes to in the function definition, you must do that. In the function definition, you must do that. And I'm just going to let this go one more time, the entire student challenge. That way you have it all together. Okay, so then there is line 47, your student challenge. Take that picture. Okay, 10 more seconds. All right, now that's it. Okay, so now let's go up and review what I did. So I'm not going to read all the comments anymore because the comments you can read. Anything with a slash here is a comment, as you know, and they're multi-line comments, but just because word wrap took care of it. Otherwise, you'd use a slash asterisk as the starting part of the multi-line comment and end it with an asterisk slash afterwards, okay? But that's all comments, so you don't need to worry about that in terms of your code. And you know your pound include. You know the pound include IO manip is because I am using set precision with fixed and show point. So you know that, okay? You know you're using namespace std. We always use it so that you do not have to type out std : coot, std : c input, okay? std : and l, so that you don't need to do that, all right? So that's that. And then here, I'm putting a comment telling you, using double function prototype to set up this program to use a function definition and a call from int main to the function. So when you're using, whether it's a value returning function or a void returning function, this is a value returning function. Why? Because it has a data type, double, okay? So, and the name of the function is number of fill-ups. And then there's one required argument in this one. In the one you're doing, there's two required arguments, okay? So int number is the only argument, and it must end in a semicolon when it's the function definition, okay? You know what int main is. It has an opening and closing curly brace. That's the opening right there in line 13. The ending is in line 37. So everything in between is all int main, all right? Okay. So then I have an integer for number fill-ups, num fill-ups, sorry. This is the loop control variable for the number of fill-ups, okay? Then we have an int fill-up num to tell us which fill-up num we're on at the time. Remember, we're going through a loop. So the first one and the second one and the third one are all fill-up num 1, 2, and 3 as we're processing the code, okay? And then double number gallons. And number gallons is going to get 3 uses too. For the first iteration through, see that we put for the user here. Let's see. Enter the number of gallons for this fill up. That meant for fill up 1, and we put 15. Okay. Then enter the number of gallons you entered for this fill up. This is now fill up num 2, and we put 16. Then enter the number of gallons for the next one, 18. So this number gallons was used 3 different times, all right? And then same with miles driven. Enter the number of miles you drove for Philip 2. Enter the number of miles you drove for this, for Philip 1, 300. 2, 325. Then enter the number of gallons the number of miles you drove for Philip 3, 350. So again, this one was used for 3 times. All right. And then double number Philips, I put to use for the user input response. This was for the value I'm using that I'm calling the function definition for. So double number Philips here is the value I'm going to get, but I'm really getting it from the user via number of Philips and then number Philips argument. Remember, this thing here is the same spelling as the double up here, number of Philips, int number, but the value for the argument doesn't have to be the same. So here I'm calling it number Philips, okay? And then it calls that procedure down here after int main closes, right there. Then double number of Philips, int number. This one has to be exactly the same as the function prototype, but here we have an opening and closing curly, and the code for this function is right here. In chapter 5's case, I had it just up here. It was in here, lines 22, 23, 24, 25, 26, something like that. But here I'm calling the function. You're going to have to call the function for yours, okay? For the one that I'm challenging you to do. And then I'm putting, again, it's just comments. I need to end this now because it's obviously going on for quite a while. But this is so you can read your comments. Obviously, we know the calculations. We know the display results. And then we know that we're using set precision. And here's the loop. We know what a loop is, but you can read, you know, and go through it to make sure it makes sense to you, okay? And then here's the function definition. Once the user calls it right here in line 22, okay, it's looking for one argument, number Philips, okay? So it comes down here, and we're using the argument name number, okay? So number. After the user sees how many gas Philips do you want to enter for these calculations, whatever he or she types in is assigned to the variable number. And then we're returning. You must return the value to the calling procedure because it's a value returning function based on the fact that it has a data type here, and it's a numeric data type even. So number is then returned. 3 was the one we did, and 3 was returned to this part, this variable, okay, which it really got from here, but then it assigns it to here. All right? All right. I hope that makes a lot of sense, and I hope you have a great day, and I shall see you in class. Let me get over here to stop my recording.